Alright, so we left off on negations, or negating something. The negation of a statement is the opposite of your original statement. So to write a negation of the statement P, you would put this little squiggle, which means not, before the letter. So we read it as not P. So squiggle P is read not P. So if you see squiggle P, comma Q, that's if not P, then Q. Alright, so writing a negation. We are going to write the negation of both of these. Remember, it's supposed to be the opposite of this statement. So if we say the ball is red, what would be the opposite of that?
The ball is not red.
The ball is not red. You're not picking a different color. You're just saying it's not red. So the ball is not red. You don't pick a different color because we don't know the opposite of red.
Is that green?
Wait, actually,
Yeah.
No, wait. It was the opposite of.
yellow.
No, it's on the color wheel. It's green.
All right. So the next statement says the cat is not black. What would be the opposite of that statement?
That is black.
The cat is black. All right. I think you get the point of those.
Probably being enthusiastic.
So flip the page, and we're going to look at the rest of our conditional statements.
I feel like I'm in science. We go to student home.
All right, so here is the main portion of this section. We learned conditional statement, that's if P then Q. We just learned negation, which is not P. Then we've got a converse, an inverse, and a contrapositive. And yes, you have to know which ones are which. So, a converse is to exchange the hypothesis and the conclusion. So instead of having if P then Q, we're going to have if Q then P. Remember last time I had you switch yours to see if it still made sense? That was the converse. So the symbols would look like Q, P. I guess I forgot to write the first one. The first one was if P then Q. That doesn't change from last class. So if P then Q. This is if Q then P. The inverse is when we negate both the hypothesis and the conclusion. So we're saying if not P, then not Q. So that would be squiggle P, arrow squiggle Q. Because a squiggle means not. So if not P, then not Q. And then my favorite is the contrapositive. We put all of them together. So first we get the converse, and then we make it the inverse of that. So we're saying if not Q, then not P. So we're switching P and Q, and we're making them both not. So that would look like squiggle Q, arrow squiggle P. If not Q, then not P.
Wait, why have to draw a line again?
The arrow?
Yep.
That means it implies the next thing.
No, for like Q.
Oh, so they don't look like lines?
Oh.
So I draw a line through mine. All right, a conditional statement and its contrapositive are either both true or both false. Similarly, the inverse and the converse of a conditional statement are either both true or both false. In general, when two statements are both true or both false, they're called equivalent statements. All right, here we go. It says, let P be you are a guitar player, and let Q be you are a musician. So we know P, we know Q. Write each statement in words and then decide if it's true or false. So the conditional statement, that's our original if P, then Q. That's our P implies Q. What would that sentence look like? We're using this as P and this is Q. So what would the sentence read? You can just say it. If.
Then you are.
Okay. Then. Okay. So if you're a guitar player, then you're a musician. It was if P, then Q. Okay, I'm going to try to switch colors here so they don't all start fading together. What was the converse? What did the letters look like for converse? If Q, then P. So Q implies P.
If you're a musician, then you're a guitar player.
All right.
Oh yeah. Oh yeah.
If you're a musician,
Wait, what?
we're switching them because it's if Q, then P. So if Q is you are a musician, then P, you are a guitar player.
We're gonna have space.
All right.
Yeah,
I want to give you time to write because I know these are kind of a lot to write here. C is asking about the inverse. What was the symbols for inverse?
If and not.
Not P implies not Q.
If you are not. Then you are not.
So if you're not a guitar player, then you're not a musician. Okay. Contrapositive. What was the symbols for that?
Squiggly Q. Not Q or not P.
Not Q implies not P. If you're not a musician, then you're not a guitar player. Don't flip yet. We still have to say if these are true or false.
How do you write this with that?
Well, if you notice, it's not really legible towards the end, so I just kind of squiggle my way through. You're going to have to use that one. That one broke. So just put the garbage can under it. Yeah. All right. So, which of these are true? Let's see. The first one. If you're a guitar player, then you're a musician. Is that true?
Yeah.
All right. So I'm just going to put a T and circle it so that I know I did that one. All right. The converse said, if you're a musician, then you're a guitar player. Why is it false? Right. You could play a different instrument and still be a musician. All right. The inverse. True or false? Why is it false? You could play a different instrument, so that one's also false.
Then the next one's true.
Contrapositive is true, you're saying?
Yeah.
All right.
So you're not a musician.
Robert. Fish. Oh, there's fish.
What's
Okie
your
doke.
fish's name?
He doesn't have a name yet.
Wow.
Flip to the next
Are
page.
you waiting to see if he brings it?
Well, I said since he didn't die yet, he probably should have a name. But I thought he was going to die for a while.
You should name him something
Like
to
just
do
like-
with math.
Name
You should name him Play-Doh.
him
Who's gonna
Rob.
die?
All right, the fish.
Somebody said name him Rocky.
I heard that.
I think Play-Doh.
Okay, so the definitions as conditional statements. So, we can write the definition as a conditional statement in an if-then form and as its converse, because if it's true one way, it better be true the other if it's the definition of something. Both the conditional statement and its converse are true for definitions.
Yep. Oh.
Okay? So the example we have is if two lines intersect to form a right angle, then they are perpendicular lines. What's the converse of that? You might want to go back and remember what a converse is.
Isn't it if P then Q? If they are perpendicular lines.
Okay, so we switch P and Q for a converse. So let's write it and then we'll see if it's true. So if two lines are perpendicular, I just write perp for perpendicular because I refuse to write that word out. If two lines are perpendicular, then they intersect to form a right angle. Is that true? If we have two lines that meet at a 90-degree angle, is it a right angle?
Yeah.
All right, so it's true for both because definitions have to be true both ways. And then I told you the symbol again for perpendicular in case you haven't seen it. It's the little upside down T, so it looks like there's a right angle on both sides.
Oh.
So if you've never seen that, if you ever want to write the symbol instead of the word, that is it. It's an upside down T because it's two lines meeting perpendicularly. All right, a biconditional. When a statement is true, both for its conditional and its converse, so like a definition just was, you can write it as a single biconditional. A biconditional statement uses the phrase if and only if. So, we write it as P if and only if Q. And the symbol, what's different about it? The arrows go both ways because we're saying it's true this way and it's true this way, this way and this way, this way and this way. So we say if and only if it can be true both ways. All right, so we're using that same definition from above. It says if two lines intersect to form a right angle, then they are perpendicular lines. So what is P? Two lines intersect to form a right angle. What would Q be? They are perpendicular lines. You can use the perpendicular symbol there if you would rather. All right, so the conditional statement is what it was right there. If two lines intersect to form a right angle, then they are perpendicular lines. The converse, which we wrote up above, if two lines are perpendicular lines, then they intersect to form a right angle. What would our biconditional read as? What would our biconditional read as? Remember, it's P if and only if Q. So here's P. Then we're going to say if and only if Q.
So two lines intersect to form a right angle, if and only if they are perpendicular.
Perfect! Now you get to write it. There's lots of writing in this chapter, so hopefully you like it, because I don't. I would much rather do numbers. All right, two lines intersect to form a right angle if and only if, oops, I got ahead of myself, they are perpendicular lines. Move it up so you can read it. Two lines intersect to form a right angle if and only if they are perpendicular lines. When you're writing these out, if you ever Google it or anything, the if and only if statement's often written as if with two F's. So if you're ever trying to read a proof or something and it says IFF, it's not a spelling error. That's the shortcut version of if and only if. Don't ask me why. I don't ask questions. So if you're ever trying to read something online that says IFF, that's if and only if. All right. We've got truth tables last, and then we're done, but we're going to take a quick break because I need to stop talking for a second.
Run. Are we running outside?
So here is a truth table.
The truth of the statement.
So the truth value of a statement is either true or false. It can't be anything else but true or false. You can determine the conditions under which a conditional statement is true by using a truth table. Our hypothesis is what letter? And our conclusion is what letter?
Q.
All right. Here we go. The conditional statement P, if P then Q, is false only when a true hypothesis produces a false conclusion. So that's the only time we get a false, is if we assume something is true, but we get a false answer, then the whole thing is false. We say two statements are logically equivalent. Logically equivalent when they have the same truth table. We are going to fill in the truth tables for the converse, inverse, and contrapositive.
So we have to write things out, like we can't just like put letters.
We're just going to put letters in these.
Okay.
Alright, so for a conditional statement, if what we're assuming is true, and our conclusion's true, the whole thing is true. Okay? If we're assuming it's true, then the whole thing was true. If we assume something's true, but then our conclusion is false, then the whole thing is going to be false. It'll make sense once we start doing actual situations, but. Alright, this is the one that always goofs me. If we're assuming something is false, so our hypothesis is wrong, but we get the right answer out anyways, then the thing's true. So it's kind of like, you got the right answer, but the wrong way, but you still get the points because you got the answer right. That's how that one works. Okay? And then the last one is if we're assuming something is false, and then we get a false answer, then it's true. Okay? So if we assume it's wrong and we got it wrong for whatever other reason, the whole thing is true because they're both wrong. This is logic. Are you ready? It's craziness. Alright, so for the converse. So this is if Q, then P. Alright, if our P is true, and our Q is true, then the whole thing is true. If P is true, and then our conclusion is false, what would it be up here?
False.
False. Wait. If Q, then P. So it would be if T. Oh boy, I'm getting goofed. No, it'd be right here. If P, so we're switching these, because it's if Q, then P. So this one should be true. Sorry. Because if we have the thing that we're assuming is false, and we get a true out, then the whole thing's true. Because we're assuming Q, and P is our answer. Alright. If this is false, but our conclusion's true, then this is the one that's false. Because we're assuming something's true, we get something false out, so the whole thing is false.
Yo, wait, what?
What? Are you assuming something?
This is this one right here, basically.
Because
Because we're assuming Q, so that would be the first part. We're getting this out, so the whole thing is false.
so then a false
Wait,
false
what?
would be false.
False false would be
Or it's still true.
true.
Okay, still true.
Basically, just copy these for now, and once we start putting words in it, you'll feel better about it.
Let's go.
The only time you can get a false out is if your assumption is true, but you get the wrong answer, then the whole thing is wrong. I'll scoot it up so you can see in the back. All right. Whew, inverse. All right, so if P is true and Q is true, then the not version of both of those would be false. So if we assume something's false and we get false out, what are we going to have? True. Bless you. All right, the next one. If P is true, but Q is false, not P would be false. Not Q would become true, because we're doing the opposite of these. What are we going to get out? Okay. Then if we had a false P and a true Q, the opposite of that would be true and then false. If we have a true assumption but a false answer, what should we get for our final?
False.
Okay.
People.
And then if it's false, false, that means we're going to get out not false, which would be true, true. And true, true is true. Because if you assume something's true, and you do your work, and you get the true for the answer, yeah.
The one at the top is true, true, false, false, true. Out of the bottom, false, false, true, true, true.
Because these two are just the opposite of these two.
Yeah.
And then we're basically ignoring this column and going back to our original truth table.
Oh.
Your nails are pretty.
Thank you.
What colors do you have?
It's called Kira.
Okay. Did you have equal this a few weeks back?
I did. I did them yesterday.
That sounds like fun.
All right. Contrapositive. There's a lot of letters getting thrown around out here, and let's see what we can do. Once we finish this, though, we're done for today.
Okay, those numbers.
All right. So let's just get these letters rolling.
Oh, yeah.
All right. So let's fill this in first. We always say true, true, and then true, false, false, true, false, false. Okay, that's what we're just starting. We always start with that. That's the original conditionals. All right. So not Q would be what? Okay. Not P would be? Okay, so if we're assuming false and then we get false out, what should we get?
False. True. True.
False, false gives us true.
Wait, these are the letters.
All right. Not Q is what?
It's true.
T.
True.
T. Not P would give us
False.
F, because P was true. So if we're assuming something's true and we get false, what should our answer be? False.
I'm a joke.
Then it'd be true, false.
This one, not Q,
Oh,
would be false. Not P would be
true.
true.
So the answer would be true.
So if we have a false assumption, but we get a true conclusion, our answer should be
True.
okay. All right, not Q is what?
True.
True. Not P is.
True.
So if T, then T.
True.
So we get T.
We love the cheese.
All right.
I actually think I'm having a brain fail.
Woo! I'm going to try to find, there's a YouTube video where this is explained really well. Because I don't love truth tables. Yes.
Are you YouTube famous for filming?
No.
You should post them on YouTube.